Hello everyone, welcome back to my channel Astrovibes. So this is going to be our last lecture of AGN series, and in this video we are going to discuss about X-ray data analysis of blazars. So let's begin. So what are blazars? In our last lecture, we discussed about different types of AGNs. We classified AGNs into different types based on the observer's viewing angle. We classified them as Seyfert galaxies, quasars, blazars, like this, right? So blazars are a special type of AGN where one of its relativistic jet is pointed straight to us. So the jets are basically a stream of fast moving particles. That is why they are called as relativistic jets. So these blazars are incredibly bright as they emit across the entire electromagnetic spectrum. So we have classified blazars into two subtypes majorly. One is BL Lac, another one is FSRQs. So BL Lacs generally has weak or no emission lines, and FSRQs are flat spectrum radio quasars, and this has a very strong emission line and they look really bright. So in my project, I majorly focused on BL Lacs, like I did data analysis of BL Lacs. So we will discuss more about it. So why do we study blazars in X-rays? Well, X-rays helps us probe the innermost or the most energetic part of the X-ray where the particles are being accelerated to the relativistic speed. As Earth's atmosphere blocks most of these X-rays, we need space telescopes to detect these X-rays. So that's where NASA's NuSTAR telescopes comes into the picture. NuSTAR is Nuclear Spectroscopic Telescope Array, and it was launched by NASA. So this is the first X-ray satellite which helps us detecting high energy X-rays. Like its range is from 3 to 79 kilo electron volts, and it literally gives us very sharp spectra of blazars and black holes and even supernova remnants. So I have shown a picture of NuSTAR right here in this slide. You can see this is a very unique telescope. You can interpret it from this picture, right? So next step is, how do I analyze this data? So my project majorly focused on BL labs. Actually, we gathered informations, like we downloaded data of different types of blazars like BL labs, FSRQs, and we collected the data of narrow line specifiers as well. But especially I downloaded the data of BLX. So first of all, I selected some sources from the new Blazar catalog. These sources are detected by the NuSTAR. So then I cross-matched this catalog with formula catalog, and then I found some unique BLX sources, and using its object name or RADEC also we can use. I used HEASARC website to download the required data. Then I reduced these data using new pipeline and new products. Then finally I used XPEG to plot this spectra, and I check whether its reduced chi-square is close to 1 or not. If it's close to 1, then it's a bit of it. So when I analyzed the data of BLAX, I found that most of my objects, like almost every object of mine, was well fitted with power law spectra. That means these energies that we were considering, like the emissions, these are non-thermal emissions. So you can see different interfaces of this websites that I use. The first one is New Blazor Catalog, and the second work is NASA's HEASARC web browser. So here you can just put your object name or the array tag of your object, whatever you have. Then you just select the type of telescope you use. Like for example, for me it was NuSTAR. So I clicked it and I just get some queries. I retrieved the data and downloaded it. And then the third one is the formula catalog. I actually cross-matched my new Blazor catalog with formula to get my unique BL lags. So here are my plots. Like the first one is a plot of one BLAC object. So this was done using XPack obviously. And it is fitted by power law. It fits very well. And the next one is a sky plot. And in this sky plot, we have every kind of object, like different type of BLX are also there, like HBL, IBL, LBL, and then FSRQs are also there, and narrow line ciphers are also there. So this sky plot is done using Python. So our video ends here. But I have one interesting question for you. Like if blazars can influence intergalactic environment over millions of years, so could they be silent architects of galaxy evolution? So this is actually a very interesting question. So I leave it up to you to think about it. So let me know your thoughts in my comment section. And thank you so much for your support and of course for your patience. Thank you so much.